Yes, very good afternoon to one and all. Am I audible to all? Yes?
Yes, sir.
Okay. So last class, we have seen that MCQ examination on first unit. Okay. So today we will have a brief discussion regarding that unit test. Okay. And afterwards we will move into the second unit. Okay. So please, anybody tell me any doubt regarding second unit, first unit test. Okay. Uh, if any, let me know. Okay, we will discuss that point. Okay. I hope without any doubt, all of you solve that test. Okay. But still, anyone doubt is there regarding that MCQ examination? Please let me know. Yes. Any doubt? I have released the score also. Okay. All of you got the good marks except some cases. Okay. So any doubt regarding that unit test? Yes. Yes. I think 40 members are joined. Okay. So near about 25 students are absent. So yes, out of 40 students, tell me anyone. Any doubt regarding that first unit test?
No doubt.
Okay.
No,
My
sir.
okay. So all of you got the what actually the question is asked and how to answer them. Okay. I hope all of you got that idea and you have solved that MCQ examination. Okay. Because this article which we have studied in the first unit that are very much important uh, as a point of examination view. It may be a university examination as well as state PSUs or some competitive examination point of view. Okay, so now almost 210 is there. Okay, but still only 42 students are joined. So please, my humble request to all of you, please join the lecture on time. Okay, so because of some climatic situation, we are getting so much interruption. So please try to join the lecture on time. Okay. So today we will move in the next unit. Okay. So constants of transmission line. Okay. For that one, total number of lectures are 7. Okay. So within the 7 hours, we have to complete it. Okay. So constants of transmission line. Into that, we have to see resistance of line, skin effect, proximity effect. Okay. Inductance of single piece two wire line, calculation of GMR and GMD. Okay. Inductance of three-phase line with equilateral spacing, unsymmetrical spacing, effect of transposition, line capacitance, capacitance of single phase and three phase line, effect of earth on the capacitance of overhead line. Okay, this is the most important unit in electrical power system because we are dealing a constants of transmission line and majority chances to ask the MCQ in this section only from the power system. Okay, in the competitive examination. So this part is very much important. So all of you please join the lecture or forthcoming lecture on the time. Okay, we will try the get the majority of concept of constants of transmission line. Okay, so resistance of line or resistance of any conductor, as we know that it is depends upon. Tell me anyone, it will be depends upon. Yes, anyone, please tell me what factors going to affect on the resistance of conductor or resistance of line, we can say. Yes, tell me anyone.
Length of material, area of cross-sectional.
Okay, another.
Resistivity.
Yes, I'm not getting your voice clearly, please. Yes, third factor, length, area cross section, and another one. Yes,
Resistivity of material.
yes, resistivity of material. Okay. So instead of these three if, factors, some another factors also there which is going to affect on the resistance of overhead line conductors. Okay, so that is what the skin effect and proximity effect. Okay, so all of us already known that how the length of the conductor going to affect on the resistance, area cross section of the conductor, how it will be going to affect, and also resistivity of the conducting material, how it will be going to affect. Already all of us know. Okay, so today we will see that effect of skin or skin effect on the resistance of line or resistance of conductors. Okay, so these are the various sub-unit articles of unit number 2, and that is what constants of transmission line. So generally the constants of transmission lines are nothing but resistance, inductance, and capacitance. These are the main transmission line uh, parameters or constants. Okay, so in these units we will study the resistance, inductance, and capacitance of line conductors and how they will going to determine by using the various supporting calculations like a calculation of GMR, GMD. Okay, calculation of GMR and GMD for equilateral spacing, for unsymmetrical spacing. Okay, and effect of transposition on GMD and GMR we will see in this. Okay, and also we will see the effect of earth on capacitance of overhead lines. Okay, so we will move in the syllabus. First of all, resistance of line, and into that we will see that basic factors and skin effect and proximity effect. Okay, afterwards we will move to the inductance of single piece to wire line. Okay, so I hope my voice is clear to all. Yes, whether it is clear? Yes, is it
Yes, sir.
clear? So resistance of the conductor or resistance of line. So I try to show you over here. Okay. So see over here, this is the conductor having length. We say capital L or sometimes it will be a small L. Okay. So capital L, it is the length of the conductor over here, and area cross section, it is denoted by capital A and resistivity R. Okay. So another factor we have forgotten to tell, that is what the temperature. It will also going to affect on the resistance of that material or resistance of conductors. Okay, so uh, resistance can be defined mathematically. R is equal to rho L by A. Okay, so this one is according to the Ohm's law. Okay, resistance is equal to rho L by A. Okay, over here actually resistance is directly proportional to length of the conductors and inversely proportional to area cross section. Okay, so that proportionality sign can be removed by substituting the resistivity. Okay, so resistivity of the material is nothing but ability of a material to oppose the flow of electrical current through it. Okay, so resistivity generally denoted by rho. Okay, and this resistivity changes material to material. Okay, means what, aluminum having the different resistivity, copper having the different resistivity, cast iron, stainless steel, silicon steel having different resistivity. Okay, so resistivity, it is totally depends upon the types of material. Okay, whether it is metallic, non-metallic, semiconductor, okay, or it is an insulator. It is totally depends upon the material. Okay, so this is a constant for the particular material. It is a constant. Okay, so resistivity, it is a constant. L, it is the length of the conductor, and A, area cross section. Okay, so see over here, the length of the material, longer material have greater resistance. since it is directly proportional. Okay, since resistance is directly proportional to length of the conductor, so whenever there is a longer length of the conductor, there will be a more resistance. Okay, so see over here, I have tried to show. Okay, having a length L, resistance is 1 ohm, and if it is length equal to 2L, at that time resistance will be 2 ohm. Means what? Mathematically, we can say that resistance is directly proportional to length. Length changes, same proportion, resistance will going to change. Okay, length 1L will be there in first case, and second case 2L. Means what? There should be increase in resistance 2 times. Okay, since the length of the conductor increases 2 times. Okay, so it is a proportionality, directly proportional there, that's why. Okay, the cross sectional area of material A. Okay, if it is in first case area cross section is A, and in case of area cross section it is 2A. Okay, it is something hidden is there. Okay, so it is a 2A. Okay, so see over here, the area cross section, how it will be going to affect, since resistance is inversely proportional to area, so resistance uh, decreases whenever area cross section increases. Okay, and vice versa, whenever the resistance increases, area cross section should be reduced. Okay, and whenever the area cross section increase, resistance should increase. Okay, sorry, whenever resistance increases, means area cross section must be reduced. Okay, whenever the area cross section increases, resistance should be decreases. Okay, and vice versa, we can say. See over here, in first case area is A, in that case the resistance of the conductor is 2 ohm, and in second case area cross section is 2A. At that condition, the resistance of the conductor is 1 ohm. Means what? In which proportion area cross section going to change? In same proportion, resistance will going to change, but in inversely proportionality will be there between them. Okay, I hope this is understandable to you. Okay, so the temperature T of the material, the higher temperature usually result in higher resistances. Okay, means what? The temperature increases, resistance should increases. So as we know that, I think you have studied resistance temperature coefficient alpha. Okay, so resistance temperature coefficient or RTC, it is totally depends upon the temperature of the conducting material. Okay, whenever the temperature increases, resistance increases. Means what? In that case, RTC is positive, and whenever the temperature increases, resistance decreases. In that case, RTC is negative. Generally, the positive RTC will be in metallic conductor, and negative RTC for the insulator, and alpha is equal to 0 for the I can't remembering that material. For that one, alpha is equal to 0. Okay, I have forgotten name. Okay, but alpha may be 0. Okay, so temperature going to affect on the resistance of the conductors. Okay, generally for metallic conductors, it is a increase in temperature, there will be definitely rise in resistance. Okay, next, the kind of material. Okay, iron has more electrical resistance than geometrically similar copper conductor. Geometrically similar means what? If we take the 1 meter long rod of copper and aluminium and having the same area cross section, we can say that 0.1 meter square. Okay, if even it is same area cross section and length of the copper and iron, okay, definitely iron has more electrical resistance than copper because of resistivity. Okay, so resistivity of the copper is less as compared to iron. Okay, as compared to aluminium. Okay, but aluminium has less resistivity with compared to iron. Okay, we can say that insulator having the highest resistivity. Okay, with compared to metallic structures or metallic conductors. Okay, so see over here how the area cross section going to affect, because uh, we are more interested for the area cross section, because of area cross section going to affect on resistance, and mainly the area cross section of the conductor is affected by the skin effect. We will see furthermore articles. Okay, so just wait 1 minute. Yes, once again we will continue. Okay, so see over here cross sectional area. Okay, sometimes it may be a circular conductor, sometimes it may be a rectangular shape. Okay, so see over here, all of us already known these things. Okay, so we will move to the next. I have summarized over here for your kind information. Take a screenshot for this one. Okay, length, how it will be going to affect cross sectional area. Okay, so before starting the actual skin effect, tell me one thing. What is mean by electrical current? Yes, anyone? Yes, tell me what is mean by electrical current and electrical current density. Okay, if we know these two terms, then you can easily understand the skin effect. Yes, tell me what is meant by the electrical current density, and effect of electrical current whenever it is flowing through the conductor, and what happens to its magnetism. You should know first of all. Okay, so tell me what is meant by the electrical current. Yes, yes, yes. Anyone? Yes, please. Yes. Am I audible to all? Yes. Is it audible? Yes. Yes. My voice is not clear to all. मी काय म्हणतो ते कळत आवाज येत नाही का? Let me call roll numbers. Yes. Roll number 10. Yes, tell me. Yes, what is meant by electrical current and current density? Yes. Yes, roll number 36. Yes. I'm asking your roll numbers means you should respond. Sir, yes, I'm audible to you. You should at least try to answer. Okay. Yes, roll number 10. Am I audible to you? Yes. Yes, roll number 36. आवाज येत नाहीये का कुणालाच? Yes.
येस सर, येतोय आवाज.
मग मी काय विचारतोय? करंट म्हणजे ऍक्च्युअली काय? करंट नेमकं कंडक्टर मध्ये कसं फ्लो होतं? आता याची काय गरज आहे इथं विचारण्याची, असं म्हणायचं असेल तर स्किन इफेक्ट समजण्यासाठी ते आपल्याला इम्पॉर्टंट आहे. कारण आपल्याला त्याच्यावरून करंट डेन्सिटी समजेल. करंट डेन्सिटी समजेल त्याच्यानंतर आपल्याला कळेल की मॅग्नेटिक इफेक्ट मुळे त्या करंट वर डेन्सिटी वरती काय इफेक्ट होतो. मग ते पुढे स्किन इफेक्ट मध्ये काय होतं नेमकं तेव्हा कळेल ना आपल्याला. म्हणून मी विचारते की करंट म्हणजे काय असतं ऍक्च्युअली. येस.
The flow of free electrons.
Okay. Have you Google search? Yes. Okay. So rate of flow of charge with respect to time through the conductor is nothing but the electrical current. Okay. I is equal to Q by T. Okay. If you take the derivative with respect to time, that is what we will get. I is equal to dq by dt. Okay. So afterwards we will get the answer, what is actually meant by the electrical current. Okay. So electrical current is nothing but what? Rate of flow of charge through the conductor with respect to time. Okay. So electrical energy is needed for the movement of electrons or charged particles or charges from one point to another point of a conductor. Okay. Whenever we apply a electrical energy, it may be a AC or it may be a DC. In that case, the electrical current will flow through the conductor. Okay. So whenever we apply the DC voltage source to the conductor, at that time, the free electrons flowing through the conductors will flow uniformly throughout the conductor surface as well as its core part. Okay. So charge density and thereby electrical current density in case of DC current flow, it is uniform throughout the conductor. Okay. जेव्हा इलेक्ट्रिकल जेव्हा डीसी सप्लाय आपण एखाद्या कंडक्टरला देऊ तेव्हा युनिफॉर्म चार्जेसची मूवमेंट होते कंडक्टर मधून. म्हणून इलेक्ट्रिकल करंट हे युनिफॉर्मली डिस्ट्रीब्युटेड असतं थ्रू आउट द कंडक्टर. ओके. बट whenever the AC supply is applied to the current carrying conductors or conductors, in that case the movement of free electrons from higher potential to lower potential is not a constant. It is a dynamic movement. Okay. It is a dynamic movement or it is a time changing movement. Okay. So whenever the AC current is applied, in that case the charged particles like electrons will not be flow unidirectionally and uniformly throughout the conductors. Okay. So because of the magnetic field produced by the conductor, which is actually developed due to the current flowing through the conductor. Okay. जेव्हा एखाद्या इलेक्ट्रिकल कंडक्टर मधून किंवा कंडक्टिंग मटेरियल मधून इलेक्ट्रिकल करंट फ्लो होतं तेव्हा मॅग्नेटिक फील्ड ही त्याच्या अक्रॉस प्रोड्यूस होत असतं इन त्याच्या सराउंडिंग्स मध्ये. डीसी सप्लाय मध्ये पण सेम होतं पण तिथलं जे मॅग्नेटिक फील्ड प्रोड्यूस होतं ते कॉन्स्टंट असतं. ठीक आहे. म्हणून charge distribution over the conductor in case of DC, it is uniform. That's why current flowing through the conductor will be uniform throughout the cross section of the conductor in case of DC. But in case of AC, the magnetic field produced around the conductor and within itself, it will be a time varying quantity or changing quantity. That's why, because of that magnetic effect, the current flowing through the conductor tries to concentrate at near the surface of conductor. Okay, near the surface of conductor. Okay, so total number of charges flowing at surface of the conductor in AC will more with compared to core of the conductor. ठीक आहे, की जेव्हा एखाद्या कंडक्टिंग मटेरियल आपण एसी सप्लाय देऊ तेव्हा टाइम वेरिंग मॅग्नेटिक फील्ड तिथं प्रोड्यूस होईल. त्याच्यामुळे काय होईल की जे काही चार्ज डिस्ट्रीब्युशन आहे सरफेस वरती आणि कंडक्टरच्या कोर पार्ट मध्ये हे वेगवेगळं असेल आणि काय होईल की चार्जड पार्टिकल हे त्याच्या सरफेसला कॉन्सन्ट्रेट व्हायला सुरुवात होतील. त्याच्यामुळे काय होईल, जो सेंट्रल कोर पार्ट आहे तिथून लेस नंबर ऑफ चार्जेस फ्लो होतील. म्हणजे current density at the surface of conductor is more with compared to current density at central or core part of the conductor. Okay, core part of the conductor. It is because of magnetic effect produced by that AC current flowing through the conductor. आता हेच प्रिन्सिपल आपल्याला स्किन इफेक्ट स्टडी करताना अभ्यासायचं. आता बघा, आपण जे आता डिस्कशन करतोय ना ते सेम इथं स्किन इफेक्ट मध्ये त्यांनी एक्सप्लेन केलेलं आहे. स्किन इफेक्ट इज अ टेंडन्सी ऑफ एन अल्टरनेटिंग इलेक्ट्रिकल करंट to become a distributed within a conductor such that the current density is largest near the surface of conductor and decreases exponentially with greater depth in the conductor. What is the meaning for this first statement? Whenever the AC electrical currents flowing through the conductor, in that case, the current density is largest near the surface of the conductor and it is decreases exponentially with greater depth in the conductor. म्हणजे यांना काय म्हणायचंय की करंट डेन्सिटी नियर टू द सरफेस ही लार्जेस्ट असेल आणि जसं जसं आपण कंडक्टरच्या सेंटर पार्ट कडे जाऊ, कोर पार्ट कडे जाऊ, तसं तसं करंट डेन्सिटी ही एक्सपोनेन्शियली डिक्रीज होत आहे. एक्सपोनेन्शियली डिक्रीज होत आहे. The electrical current flows mainly at the skin of the conductor, we can say. Okay, current density ही जास्त आहे at the surface. याचं meaning काय आहे? Current, electric current flows mainly at the skin of the conductor. Okay, so we can say that skin effect is nothing but what? The flow of electrical current mainly at the skin of conductor. Okay, this is nothing but the skin effect. Okay, skin depth. आता स्किन डेप्थ काय असते? आता स्किन डेप्थचं आपण एक्सप्रेशन पाहणार आहोत आणि स्किन डेप्थ पण म्हणजे काय असते ते ऍक्च्युअली पाहणार आहोत. आता या पिक्चर्स मध्ये बघा, ही ब्ल्यू कलर आणि रेड कलर सेम आहे, म्हणजे डायग्राम सेम आहे. ठीक आहे, सॉलिड कंडक्टर आहे हा, no current flow, concentration of current over the surface. Okay, so see over here, this is a solid conductors, this is the no current flow region and concentration of current over the surface. See over here, we can say that no current flow at the core of the conductor only because of the skin effect. Okay, because of the skin effect. Okay, so concept of skin depth is what? It is the we can say that distance from the surface of conductor up to the point where there is no current flow in the conductor. आता बघा स्किन डेप्थ म्हणजे काय आहे, सरफेस पासून ह्या इथपर्यंतचं डिस्टन्स आहे, याला आपण स्किन डेप्थ म्हणणार आहोत. ठीक आहे, हे डेल्टानं दाखवलं जातं आणि हे एक डिस्टन्स आहे. ठीक आहे, आणि ह्या स्किन डेप्थच्या नंतरचा जो काही हा फेंट कलर दिसतोय, मी आरो पॉइंटर स्लाइड करतोय बघा, फेंट ब्ल्यू कलर दिसतोय, हा ऍक्च्युअली कोर पार्ट आहे कंडक्टरचा. तिथून करंट काहीही फ्लो होणार नाही. का? तर स्किन इफेक्ट. ओके, स्किन इफेक्ट मेन रिझन काय आहे, स्किन इफेक्ट. तर आपण पाहणार आहोत की ऍक्च्युअल स्किन इफेक्ट का पिक्चर मध्ये येतो, म्हणजे रिझन किंवा कॉजेस ऑफ स्किन इफेक्ट. ओके, सो skin effect is caused by opposing the eddy current induced by the changing magnetic field resulting from the alternating current at 60 Hz in copper. The skin depth is about 8.5 mm. At high frequency, the skin depth becomes much smaller. Okay. आता बघा, actually, whenever a AC current will flowing through the conductor induces a magnetic field. Okay, as I said earlier, whenever the AC current flows through the conductor, it will going to create a magnetic field around itself. Okay, आपल्याला माहिती आहे की according to HC Oersted, whenever a current flows through the conductor, it will produce a magnetic field around itself, and it is given by the right hand thumb rule. Okay, so right hand thumb rule आपल्याला माहिती आहे. right hand thumb rule काय सांगतो? Yes. Yes, these are the basic laws of electrical engineering. Right hand thumb rule. Right hand thumb rule, it will give you relation between the direction of current flowing through the conductor and magnetic field direction. Okay, if we hold the conductor in right hand in such way that curled finger wrap around the conductors and outstretched thumb. Okay, in that case, our curled fingers represents the magnetic field direction and outstretched thumb represents the direction of flow of electrical current. Okay, so this is according to the SC or right hand thumb rule. Okay, what I am going to say over here, whenever a AC current flows through the conductor, it induces a magnetic field H. Okay, this is magnetic field intensity. Okay, if the current increases as in this figure, the resulting increase in magnetic field induces a circulating eddy currents IW. Okay, म्हणजे जेव्हा एखाद्या कंडक्टर मधून चेंजिंग करंट फ्लो होत असतं तेव्हा त्याच्या अक्रॉस होणारं डेव्हलप होणारं मॅग्नेटिक फील्ड ही चेंज होतं. ठीक आहे, सपोज आय नावाचं मॅग्नेट करंट या कंडक्टर मधून फ्लो होत आहे, तेव्हा एच नावाचं मॅग्नेटिक फील्ड याच्या भोवती तयार होईल, आणि मग हे चेंजिंग मॅग्नेटिक फील्ड मुळे काय होतं की तिथं सर्क्युलेटिंग एडी करंट्स फ्लो व्हायला लागतात. इथं की रेड सर्कल्स दाखवलंय बघा, IW ने रिप्रेझेंट केलं आहे त्याला. ठीक आहे, मग what will happens to this eddy current and actual current. Okay, तर एडी करंट्स आणि ऍक्च्युअल करंट्स एकमेकांना काय करतात, कॅन्सल करायचा प्रयत्न करतात एकमेकांना. ठीक आहे, एडी करंट and actual current tries to cancel partially to each other. Okay, and it is actually happen at the center or core part of the conductor. Okay, and because of that one, central part of the conductor act as a highly resistive. म्हणजे काय होतं, एडी करंट आणि मेन करंट हे एकमेकांना अपोज करतात, आणि मग हा सेंट्रल पार्ट काय करायला लागतो, रेजिस्टिव्ह पार्ट म्हणून इफेक्ट करायला लागतो तिथं. ठीक आहे, म्हणजे मेनली स्किन इफेक्ट हा पिक्चर मध्ये येतो एडी करंट्स मुळे. ठीक आहे, आणि एडी करंट हे कशामुळे डेव्हलप होतात, तर मॅग्नेटिक फील्ड मुळे एडी करंट्स हे डेव्हलप होतात.